So good afternoon, everyone. Today I'm going to talk about some fundamental concept of blockchain, right? Okay. So, what is the blockchain structure? Basically, it's a series of blocks that linking to the previous. Okay, and for each block, you can store those transactions. So when you have those linked together, basically, it's can be reviewed as a linked list. It can be viewed as a linked list. So if you already took the data structure, you should know about what is a linked list, right? Okay. Okay. So I'm go over to that. Okay. So first, I'm going to talk about what is under the blockchain, right? The structure. So the main idea under the hood is called a hash function. Okay. A function can be used, what is a hash function? Hash function actually is a function that can be used to map data of arbitrary size to a data of fixed size, okay? For example, one of very famous is called a SHA-256, okay, SHA-256. It's an algorithm that can map arbitrary data size into a string with a length of 256, all right? If you have cell phone or any laptop, you can try to utilize this website. There is a free converter to generate a hash. All right. So I'm going to show you some example. All right. Assume this black box right here represents the hash function. Okay. Oh, would you mind to open the door for Dr. Wayne? Okay. So assume this black box right here represents a hash function. Basically, if I provide different documents, for example, I have document A, B, and C, if I fed those documents of any size into the hash function, I should produce different hash codes. Right? So on the right-hand side, I represent different hash codes with different colors. Okay. So if you have computer, you can try. If I'm using the SHA-256 to generate a hash code for blockchain essential. See what we'll get using the website, right? You want to try? Okay, first you can go to this website, www.freeformatter.com SHA-256 generator. Okay, you can try. I forget to mention to let everybody bring their laptop. Right? So if you enter blockchain essential, all capital letter, right? Okay, and see what we'll get.
Is that what you?
Yeah, it's a really long string.
It's a really long string with.
Yeah.
256 bits.
Okay, let me show you. If I put blockchain essential, I should get a long string, something like this. Right? Okay. So basically, this is the content. And based on the hash function, you generate a hash code. All right? Okay. Why hash code is important is because if you can try, just simply change one of the character. For example, I change the capital B to lowercase b. Okay? And see what you get. You will get a totally different hash code. All right? Okay? So for example, if I change to lowercase b, I will get a totally different code, right? So why the hash function is important? Because you can fit any document size and generate a kind of like a fingerprint. And this fingerprint hash code actually can represent, it's coming from the original document, okay? Any modification of the original document will get you a different code. So this is how the concept, how we can prevent anything changed in the original document, right? Okay, but how this is related to blockchain, right? Okay, so this is trying to compare them, okay? Blockchain, the structure, as I show you, it's a linked list, all right? So basically, at the very beginning, we call it genesis. If I forget to mention that in the first slide. Okay, the first block, also known as genesis block. Okay, that means the first block. Of course, before the first block, there's no more block, right? So basically, okay, so if you have a block, the previous block, the hash code of the block header will be stored in the next block. So for instance, this is the first block 1, right? Its header, we will generate a hash from the whole things, and also we store the hash in the second one. So basically, the hash of the previous block will combine with some data together, and then we will create another hash, and that hash will be stored in the next one as well. So this looping process is kind of a chain reaction. So the previous hash code will be stored in the next one and will combine with the new content and store in the next one. How this can prevent data change, okay? So for instance, that's why I say, let's say if we have 3 blocks right here, when we create a first block, we will create this hash. Okay, for instance, I use a shorter one. Assume the hash code is 1Z8F right here, okay? And that 1Z8F will be stored in the second block as well. And basically the previous hash block, that previous hash along with the new data will be put into hash and generate a new hash code, 6BQ1, and that one will be stored in the next. So how hash code can detect anything modification to the content change? You can try to match the hash code. If the hash code is not matching, for instance, the block 2, the hash code, the current hash code is JC6B421Q7, right? It's not matched to the previous one. You know, someone modified the content. All right? Okay? So this is how the hash code are used in the blockchain to detect anything modifying the content. Right? Okay. So also, how do we know? Actually, one of the block in the blockchain actually can store multiple transactions, not only single transaction. Okay. So this usually we use a hash tree. Okay. The root of the hash tree, actually that hash tree is typically referred to the Merkle tree. And the root node of the Merkle tree will be stored in the block, right? Okay. So for instance, a Merkle tree looks like this, all right? So how do you read this? Assume you have, in this case, I'm demonstrate with 4 examples, 4 documents. Assume I have 4 transactions right here. I have L1, L2, L3, L4 are 4 documents. I want to keep it in my block, all right? So those 4 documents will fed into the hash. So each document, for example, L1 fed into the hash function, you will get a hash, for example, 0-0. This is hash code. So this hash code actually represents L1, right? Okay. So any modification to L1 will cause the hash